I want to include you in a little conversation we're going to have. Just all of you, all of our closest friends here. Thank you again so much for your attention. I think that's great. Well, it's a pleasure to actually sit down. You must be exhausted getting off the plane, and then we threw you straight into a radio show. How did that go this morning?
I think the guy did a good job. I don't know. I hope I did okay.
Do you remember it?
Yeah, sure.
Good.
The only challenge is he asked, about American politics, but
we're not going to go there. We're not going to go there. Now, I wanted to talk to you a little bit about one of the things I read is you don't tell your team what to do. Now, I think this is really interesting, and what I've read about you is you're a fabulous mentor, some great comments about what a great teacher you are, but you're a bit hands-off, aren't you? You're a bit free-range with your team. Tell us a little bit about that philosophy.
It's interesting, Graeme and I were just talking at dinner about that. So, one of my wife's best friend, she's a professor in the United States, and but when she did her PhD thesis, she, interviewed about, many people in our lab. And she called what we do what I do is guided autonomy. That was a phrase she came up with. And what she meant by that is you're exactly right. I don't tell people what to do. I maybe give them a high-level idea and then ask them to, try to define it more. And we keep discussing it until we really define exactly what the project will be. But I think if you tell somebody too much what to do, they'll never become great themselves. It's really important for people to struggle a little bit to try to think about what's going to work, what's not going to work. But I think somebody like myself who's a professor, you can be there as a guide to say, well, maybe have you thought about this? Have you thought about that? And so I guess that's kind of what I do. I don't want to make it sound like I've got it totally figured out, but I mean, it's kind of just a style of working with students and postdocs.
But it gives people autonomy that they can do their own thing and also fail on their own terms. But so when it comes to actually getting problems solved, though, when somebody's going down the wrong track, how do you correct and realign?
Well, so what I've noticed is that people always make appointments with, say, me, and if they make appointments a lot, usually that means they're going down the wrong track.
So you don't want to see them in your office very often.
No, actually, I'm actually fine, but it's always interesting to me when things go well, the students don't feel that they need you. They know or that much, they're happy to talk to you, but it's not. But if things start going bad and they're depressed and things aren't working, well, then, they make appointments a lot. And then I said, well, just to pick an example, some people feel like even if it's a certain type of technique that's been published before, they've got to be able to do it themselves. But then if it doesn't work, they keep doing it, it doesn't work. I said, well, why don't you call the person who at University X that did this, and maybe, or somebody else that worked with them, maybe they can help. But a lot of people don't want to do that. So you try to encourage them to, why spend months repeating what somebody else has already done, as an example.
And you choose people to work with you that have the ability to collaborate well. So it's kind of like, I was talking to somebody the other day and they said, what's Bob Langer like? And I said, he's like Simon the Likeable from Get Smart. Don't you think? Yeah.
I was the person.
Yeah. But the idea is you do better work with people that you like. So I think part of your philosophy, correct me if I'm wrong, is about the ability to collaborate well, not just collaborate.
Well, I completely agree with that, but the point about people getting along with each other and wanting to interact and wanting to be collaborative, if you have a lab, especially a substantially big lab like ours, if somebody doesn't get along with somebody, if somebody is mean or other things, that's going to be a disaster. So you really want people who want to work with each other, who will be positive. This is going to sound simple, but I like having nice people, and that makes such a difference because they'll be nice to other people and younger people and help them.
But it's about respect, isn't it?
It is.
You know, the kindness in being
Yeah.
generous and being able to collaborate and help each other.
Yeah.
Yeah, rather than compete. Now, one of the things you do that I read as well, so I've been stalking you a little bit.
Yeah, it sounds like it.
Yeah, I know. Well, I'm good. I do that quite a lot. But
You have to tell me more about what you've learned.
oh, okay, all right. I'll send you a message. But the other thing that I read about too is you have quite a large turnover in the lab, and I think this is a real balance between expertise and going deep, and then having that turnover. And I once heard somebody, another person in innovation, say it's like ideas flow. It's like leaves on a stream, and you actually want flow. You don't want to keep people stagnant in your organisation. So new people come in and see things in a different way. Is this true? Sometimes people are in there for a very short time.
Yeah, well, we have people at all different levels, like visiting scientists. Actually, Callum, who's here, from Melbourne. I'm not
How
sure
did
where
he go?
Yeah, there he is.
Did
So-
you intern, Callum?
Yeah, we should. But seriously, like he was in the lab, and so that was, I don't know, was it about 3 months or 6 months? I can't remember the exact. But we have people at all different levels, right? Very senior people. Not that he's that old, but
I know you're going to say he's not that he's that senior. He is actually.
But senior, very experienced people.
Yeah.
We have people who have on sabbaticals, like as young professors, people who are postdocs, people who are graduate students, people who are undergraduates. I've had high school students. So, so people are there for all different lengths of time. But I do think it's collaborative and everyone learns from each other. And I think it's good to have fresh ideas. And again, part of it's that we're an academic unit, not a company. A company, I think, you have to focus a lot more on doing one or two things really well at a company. Here we're trying to discover things and trying to train people.
Now, you're involved with a lot of companies, and I think you're the go-to guy. When somebody's looking for a fantastic new chief scientist or chief engineer, you do a great job of championing people and leveraging them up into companies. But MIT has quite an ethos around startups and having academics working in the startup space. Tell us a little bit more about that, and is that very much generated through your lab, or is this an MIT-wide approach?
Yeah, I think it's something that's evolved. I mean, I have maybe, I don't want to say the advantage, but I've been there now 50 years, or close to 50 years. So I think with the startups, it did start happening in the 70s. I was one of the people who was involved early, but there's certainly plenty of others. In our lab, we've kept doing it. Most of those people in the 70s, they probably retired, but we've kept doing it. But there's plenty of people, and I think it's something that students have really enjoyed and found very fulfilling, starting up companies. And so now I think it's very common. And of course, Cambridge and the Kendall Square area around MIT, it's like been a real epicenter of companies and biotechnology in particular.
Yeah, great. Well, there's a whole lot of Australians coming over to Boston next year. We're hoping you would host dinner.
We can do.
Did you hear that?
Well, the food here was very good.
Yeah. No, we're all coming over to Bio, so we'll drop in and we'll knock on your door. Is that okay?
Let me know.
Yeah, all right. I'll let you know. Yeah, no worries. One of the other things I wanted to ask you about is the idea of platforms. So this is. I think, when you look at mRNA and how just versatile that as a platform is, that's mind-boggling. How do you decide which direction to go in when you've got so many uses and so many applications in a platform like that?
Yeah, well, I think that's a great question for which there's not an easy answer. It's a team effort. When we started Moderna, for example, I remember we asked McKinsey to come in and do an analysis to help us figure that out. I don't know that we've necessarily followed that by any means, but still it helps you focus. And then, so you start it, you develop it, and you keep talking to people and thinking, and of course, time itself helps you figure it out because sometimes there's advances in some fields and not in others. But I think that's a starting point. And it's really a team effort. It's a team effort between clinicians, business people, and scientists, thinking about what things should be your first, second, and third priority. But the great thing of having a platform is that you can kind of use the same base technology, maybe even the same manufacturing platform, and it's kind of almost what I'll call a plug and play. And that really gives you to pick a hockey analogy, shots on goal, and some may not work, which is okay. You'd rather them all work. But if some work, a couple of ones that work well, it makes you in an incredibly successful position, and you've helped a lot of patients.
In Australia, we would call that a magic pudding.
I hadn't heard that.
Yeah, no, I'll send you a link. But it's a very famous poet, and this pudding just kept on regenerating.
I wonder if it tasted good.
Probably. You can use that quote if you like, as long as you recognise that I gave it to you.
I'd be happy to. I need to see more.
I'll send it to you. But it's a magic pudding. It keeps on giving. It keeps on regenerating.
That's good.
So, yeah, it never runs out. I was wondering too, just the idea of thinking about culture and thinking about the next big thing. You have a huge reputation and everybody must be using your time or asking for your time, just like we have. How do you make decisions on where best to apply your energy? And knowing, are you still getting the excitement out of walking through that front door at MIT every day?
Yeah, I still get that excitement. Part of it's about the people, and about the students. I mean, I guess I try to look at things that I feel where I can make a difference. Certain things I feel, and certain people I feel I can make more of a difference than others. And of course, I feel the biggest allegiance to people that have come through our lab and that I've been involved with. Especially if they need help, then I might be able to help in some small way. But yeah, sometimes it's a challenge.
So if I could grant you one wish, and that was, I'm going to give you the opportunity to see that, I'm now in charge. I'm going to give you the opportunity to change one big thing, to discover one big thing. There's only limited time left. What's the one big thing you want to discover or change?
Well, if it's me personally, I mean, that's different than, I mean, of course, if I could wave a magic wand and have anything get discovered, probably be to allow people to live long, healthy lives. For me, I mean, I don't think I know enough about how to create longevity, but that's certainly a dream for a lot of people. But I think there are probably portions of it, maybe we can understand things about the brain, in a better way, and about the heart. We're working on ways to deliver drugs to both those places that hopefully can make a big difference. But maybe we can do more than that. When I showed that last slide, we've developed a way to make even specific human brains on a chip, where you might be able to interrogate things, where you could take somebody who, say, has ALS or Alzheimer's and really learn things that you could never learn through animals or people, just because you have so much more control of the entity that you're studying.
Yeah, it's a revolutionary space to be in science and technology at this given point, thinking about gene therapies and cell therapies, but also new drug delivery systems like nanoparticles, and it's extraordinary. And personalisation of medicine, I think, is going to be fascinating, both the regulatory and the reimbursement pathway around that. Big challenges there. So we're going to do something a little bit different, I think. Are you up for a challenge?
Whatever you want. Maybe I should be careful.
No, they won't tell.
Okay.
Come with me. What we're going to do is we're coming down to talk to you, and because I know so many of you in the room, I could possibly walk up to you and come and have a little... Look how many people look down. Did you see that? Careful.
Yeah.
So we're going to have a little walk around, and so this is your chance. I feel like a teacher. This is your chance to think of a question.
My name's Andrew Batty. I'm a medtech executive and currently the interim CEO at ACMD, with a dodgy moustache supporting my son for Movember. So I'll move over here so I don't have my back. Lovely to meet you. I don't have a clinical question. I was absolutely fascinated today by the stepping on a rake syndrome, is what I call your scenario, where you get hit, you fall down, you get hit, you fall down, and you keep going. But can I ask from a personal question, and this is probably a medtech executive question, is how do you balance your drive and your goals with your family life?
Yeah.
With being able to get to your kids' sporting events and being able to sort of be there for your partner and
Right.
and for your family members and things like that?
Yeah, well, I have to, it's a great question, and I have to give enormous credit to my wife, not me. And so my wife, Laura, we've been together 38 years, I think married 36, and she has her PhD from MIT in neuroscience, but she actually, what's been good is she is what I call a great communicator. She tells me exactly what she thinks. And that, but that is, yeah, but it's so.
So she's the fun controller.
Yeah, well, that too, but really, good communication just is so important. So, for example, when my kids were little, I mean, now they're all in their 30s, but when they were little, she said, I know you might need to travel some, but I would like you to be home every night when you're not traveling by 7 o'clock to spend time with the children, and not necessarily even her, but with the children, and help put them to bed and stuff like that, and which I did. And of course, what I've tried to do beyond that, not necessarily just because she said that, but because I also like, to spend time with them and with her, is, and this may sound, people may think I'm crazy, but probably the fact that I'm flying to, if you look at my week this week, I was in Seoul for a day, and I flew to Tokyo, and then I was in Tokyo for less than a day, and I flew to here, and I'm here for a day, and I'm flying to Hong Kong. So you get, so I don't ever stay, I try to do the thing that I can do that I hope will have some positive impact on a place. But I really try to, even now, not try to be away for too long, either for the lab or for home. So the story I've often told, which is true, is I'll just pick Israel. I could have picked other places, but 5 years in a row I had to go to Israel for something like an honorary degree or speech or something like that, and none of those 5 times did I use a hotel. I just
Stayed with friends?
No. I just the airplane. I mean, so basically you can do that. You can. I mean, so the point is I wasn't gone very long. You can get a flight from Boston to Newark or New York. You can take one of the flights and it goes to Israel. Say it gets there at noon, but Israel, they have flights out of the airport at 1 a.m. So I would do my thing and then I'd fly back and I'd be home. But both nights I'd be on the plane. But the point I guess I'm trying to say is I don't spend, and a lot of people think it's nuts. I even say, though, I don't get jet lagged when I do that. So I try to make a priority of the family as much as I can. I mean, maybe it's not smart, but health-wise, but I think it's okay, so I keep doing it.
Well done, thank you.
Thank you.
Did you get a photo? Yeah, right. I'm glad you're still married. Yeah.
Like I say, a lot of it, I think my wife deserves all the credit for.
Yeah, Luan, can we please send Dr. Langer, because your wife is a neuroscientist?
She's got a PhD in neuroscience.
I knew
now
that because I Googled you.
She's
yeah.
doing a lot of art. That's what she...
Oh,
yeah.
There you go.
Yeah.
There you go. STEAM as well. Let's have a little walk around here. There's somebody I think you should meet over here. Did that just make you sweat? I was actually coming to Sue. That was cruel, wasn't it? Sue McClellan.
Very nice to meet you, and thank you so much for getting on that plane and coming here and doing the most extraordinary presentation. I'm someone who's a director of a number of companies and I work as an advisor in the sector. And it really resonated with me when you started to talk about those problems that you had earlier in your career, and the fact that you have to be a bit resilient and you need to be able to brush yourself off and get yourself up and dust yourself off and get out there again. Interested in the role of mentors in your life and also how you work as a mentor.
Yeah, well, it's a great question. So for mentors, I talked in the lecture about Judah Folkman, who was my postdoctoral advisor, and he was a great mentor in a number of ways, but way one was just as a great role model because he experienced a lot of the things that you said. People ridiculed that work and said it couldn't be true, and I think more by example than anything else, even though I was very close to him, I think that was a great thing for me to see, that somebody could come up with big ideas, people told him it was wrong, and he wouldn't stop. So, and he also did something that I think is a great way to run a lab, which is what I call positive reinforcement. A lot of people ask me, when they've been to our lab, and sometimes people come in at odd hours, like even at 2 in the morning, and they say, well, why is everybody in your lab working so hard? Is it because you order them to do that? And I always say no. I said, I don't ever want people to work hard because they have to, but because they want to. And I think if people feel that the mission they're working on can really change the world, and if you tell them about the positive things they're doing and how they're making the world better, they're moving closer and closer to that goal, I think they work harder. So he was a great role model in a number of ways. And then I was also lucky when I didn't actually have that many people when I was at MIT who were older than me, who were good mentors. But I've had a couple friends who were my age, Alex Klebanoff and Mike Marletta. And, I remember we would have lunch every Saturday and sort of trade stories and stuff like that. And they're still two of my closest friends. And I think having people that are going through the same experiences as you are and sharing that meant a lot to me. And so those were the things that gave me the most support along those lines.
Yeah, so I guess the message is for all those early and mid-career researchers, go find someone that you admire and ask them to have that virtual cup of coffee and help them on their way.
Yeah, but I think it's more than a cup of coffee, But I think somehow having a good mentor and having really close friends that you trust, I think those two things mean a lot.
Thank you very much.
Thank you.
Nicely done. And down this way.
That's a great question.
That's a good question. Are you making eye contact? Always. John Carroll, it's your turn. Come on down.
Thanks very much. It's great to see you again, Bob. We met just a couple of years ago with Nathan Elia.
Yes, I remember.
To your lab. It was good fun. And one of the things we were really impressed with was obviously the innovation aspect of what you've done and how you've moved from research into, as you said, you're inspired to change lives rather than that 0.1% of fuel efficiency. How can I use my chemical engineering to change lives? So I'm really interested in a little more around how you've gone from the research into the industry and how you started a company with such a cool name like Moderna.
Well, that a lot. When you go into that, for me, it's been evolution on getting companies started. What happened to me, I remember in the 80s, people would come to me because there was a lot of venture capital, and they'd say, well, I've read about what you do, and would you start a company? And for the longest time, I didn't. But then I could see, as I maybe mentioned in the talk, that just getting big companies involved didn't do it. Yeah. So that made me think, well, okay, we should do it. And so we get started with my students and with the venture companies.
Yeah. So I love that phrase, right? We should do it. And there's so much in that for a lot of people in their careers. Is just getting into it and doing it rather than wondering, should I do it? There's a real step change in actually getting activated to do stuff that could make a difference. And being in your environment in Boston, I think that's at the time would have been pretty critical.
Well, I think that was good. I agree with that. But I also think, like I say, and I don't think it was just Boston. I think it was, like I say, people like Dr. Folkman and others and people always, make the biggest difference. Just what we were going over about role models, because role models can be anywhere, and you don't know. And I think if somebody sets a great example, you think, well, maybe I could do a little bit
Learn
of that.
a little bit from that.
Yeah, and I think even in our lab, what I've noticed is on the company thing, maybe I started doing it, but then I remember one of our postdocs, like David Edwards, well, he decided he wanted to do it. I'd help him.
So can I ask, how many of your postdocs have gone out and started a company? You probably had a few postdocs.
Oh, a few. And the problem is I actually don't know. But it's a huge number because a lot of them have started them directly because they're the CEO or the head of research. And a lot of them have become professors and have started them. I mean, I think, I can think of a number of my students who became professors who've started 4 or 5 companies. Yeah. And
they've had a great mentor, a great role model in how to do that. So
maybe
it's really impressive.
But people see things and they think, well, I can do it too. And I think that's important. That they realize, that's not impossible.
That they can do it.
That they can do it. Yeah.
Absolutely.
Exactly.
Yeah. Great. Thanks. Lovely to talk to you.
You too.
See you soon.
Great questions.
So John now owes me lunch because he did like 4 questions. Did you see that? Oh, no, that was rude, wasn't it? But they were good questions, so I'm going to give them to him anyway. So let's have a little walk down here. Let's see who's down this way. Oh, I know somebody who I think probably has a question. So this is one of my very, very fabulous colleagues at Cerulea Clinical Trials, Lauren Ayton. Could you introduce yourself?
Thank you, Michelle. I'm very, very starstruck to be able to speak to you, Bob, so thank you. Yes, I'm Lauren Ayton, so I work at Cerulea and CRI doing ophthalmology research and Associate Dean of Innovation and Enterprise in our medical faculty. Wow. You have done so many amazing things, and when you were mentioning before about people feeling motivated to work hard, I think everyone in the room would agree that working with you would absolutely give them that motivation. I'm really interested in what your proudest achievement is in a work setting, because you have impacted billions of patients.
Yeah. Well, really, I mean, this may not be the answer you're looking for, but my thing I'm proudest of is really how well my students have done. You know, they've become professors all over the world, started companies, and I think, I mean, not to brag too much, but I think 48 have been elected to the National Academy of Inventors, 26 to National Academy of Medicine. This is in the U.S., 23 in National Academy of Engineering. So, and I just feel it's not just the honors they've won, but you know, the things they've done and the leadership they've shown. It's kind of like, I feel like my students and postdocs, they're not my children, but they're actually not that far away. And when they and when they got something good happens for them, it makes me happy. And unfortunately, I've seen the downside too, and it makes you feel sad.
I think that's what makes you an amazing leader. Thank you, Bob.
Thank you. Thank you.
Get a good photo. Thanks so much, Lauren.
Yeah, did you like-
That's great. Lauren's a real superstar. I'm a bit starstruck. Right, coming over here, I see somebody else. I know there's a question brewing over here, and I'm going to make you two fight it out. So it's either Alicia or Bella. Which one is it? Right, rock, paper, scissors. Go on.
Oh no.
Right.
I'm also quite starstruck. We
Oh, please,
took a
I'm
sneaky
going to be
selfie
so
behind you
embarrassed.
just before. Thank you so much for your presentation and for giving your time and being here to inspire us all. I'm an engineer, biomedical engineer, and I feel like engineers have a particular way of thinking about things. And I'm listening to your oration tonight, really curious to know if you think the engineering way of thinking brings a different way of approaching problem solving to perhaps someone who's come from a medical or biological background, or if you think maybe the gap is not really there. I'm curious to understand what you think about what engineering brings to some of these biological system problems.
Yeah, well, I think it's a very interesting question. I do think that engineers, you know, engineers, you really aren't just even thinking about necessarily basic work. I mean, you could be, but you really are thinking, how do you solve that problem? You know, that's really the be-all and the end-all. Whereas I think, you know, different people in medicine, you know, they think about things a different way. I remember I'll see if I can remember this. Dr. Folkman, who I mentioned was my mentor, he had several jokes that he used to use to try to illustrate that. He was saying, well, somebody was in, I don't know if people have been to Cambridge, you know, there's the Charles River, and you walk down it, and he said, well, this doctor was walking along, and he'd noticed that somebody was drowning, and he swam out and tried to bring the guy back, and he brought the guy back. And he walked a little further, and he saw another guy drowning. He you know, tried to bring and he saw a third one. He got, you know, keeps walking up. He's getting exhausted, and then finally, you know, there's a fourth guy, and he sees this engineer, and he says to the engineer about this happening, and he says, can you do anything? And the engineer says, geez, you know, I think what I'm going to do is walk upstream and see who's throwing them in.
Excellent.
He had a few
Ouch.
other jokes along those lines, too.
Put your hand up if you're an engineer in the room. How many have we got? Keep it up. Right up, right up, right up. Okay. Over here. Oh, there's a few over here. That's fantastic. Put your hand up if you want to be an engineer now. Yeah, me too. I do. I used to say I wish I did economics, but now I wish I did engineering. Thank you. Thank you very much.
Thank you.
All right, come on over here. I think I see somebody else that I think we should talk to. Oh, hello. You made eye contact. CSIRO.
Scary me.
Scary you.
Hi, again, I would say that's just fantastic. Thank you so much. I loved it. I'm just fascinated with what you said about giving people space to do their own thing. You know, now I'm going to say I'm an incredibly controlling person, and so I want to know how to let go. So tell me more about how you actually just give people the freedom to make all their crazy ideas work.
Well, yeah, so that's a really interesting question. Some people, and I mean, there's some great professors at MIT, but I know some of them told me, well, they're what they call control freaks. You know, and I feel like I'm the opposite of that. I think you just have to feel like what's important to you. And I feel, well, first I feel like I don't know a lot of these things. And if I don't let somebody get a chance to explore and make mistakes, you know, then I don't know that they'll be as good later on. But I also don't want to oversell what I know. Yeah, and I don't know a lot of things. So I think giving people space, just realistically, they may do a better job than I would have anyhow. And then I think separately, you just have to say, well, what really is your goal? If your goal is to solve a particular problem, well, there may be, if you have the time, there may be value in being a control freak. But if the goal is to turn out somebody who's going to be a leader, you know, then you don't want to do that. And that's where the thing that Amy, my wife's best friend, said about guided autonomy, well, I think you can do that too. Anyhow, that.
Fantastic. Thank you.
Beautifully said.
Food for
Yeah,
thought.
fantastic. Food for thought. Now, there's somebody over here that I want you to meet. And I'm certain she's got a question. She's got a lot of questions, and I'm going to give the microphone now to Amanda. You knew I was coming over to you. I know you were looking down, but I know I'm going to get you to have the last question.
Great, thanks, Michelle, and again, a delight to meet you. You've been a hero to many of us for quite some time. So I'm Amanda Caples, Victoria's lead scientist and a pharmacologist by training, and I'm tossing up between two questions. The first question is perhaps something that you could expect, which is to understand your views on the role of government in stimulating the innovation ecosystem in the US. But what I really want to understand the answer to is angiogenesis. So you talked about the angiogenesis blockers. Will we ever see therapeutic angiogenesis actually work in the clinic?
Yeah, well, I think that's an interesting question, and people have I'll go second and then first. But I think, you know, people have tried to do, looking at, say, VEGF, not everybody may know what you know, but things that could stimulate blood vessel growth, and they do exist, and you know, do gene therapy or give them directly, say for heart disease in particular. And I'm actually not sure why we haven't done better. I mean, I'm not expert enough to know, but I'd like to think that certainly could work. I don't see technologically, you know, why it shouldn't work, at least that you could make new blood vessels. Whether that will really solve the problem of heart disease, you know, that's a broader question. There may be other issues at play. So I think you'd probably have to look at it, you know, really dig in deeper on to the question you asked, is there an application where bringing new blood vessels not only makes scientific sense that you could do it, but makes therapeutic sense as well. And I just haven't done that analysis. I've watched people do the thing in heart disease, and I would say so far I haven't seen, you know, a treatment. I mean, you can get new blood vessels, but I haven't seen a treatment that's emerged. I'd like to think, I don't see any reason why it couldn't, but I think we'd need to know more and dig deeper. On the first question, government, boy, I mean, I think there's a number of things that could be done that I think, well, again, if I look at the United States, I mean, one of the things has to do with money. I mean, scientists don't, especially in the healthcare area, money is so important. So when I look at the United States, things like low, you know, capital gains tax, I think is important. Things like tax breaks for philanthropy are important. There's something called the Bayh-Dole Act that they had in the United States in 1980 that enabled companies to get like an exclusive license to patents, and that came from my university. I think those things help. But anything that encourages, investment in doing research that can change the world. And it's usually high-risk research. So if it's high risk, there's a high chance of failure. So some way making sure that things are set up in a way that the risk-reward ratio for those makes sense. That's just a super high level, but that's how I think about it. Thank you.
Thank you. That's great. Well, I'm not going to come around again, but if you've got a burning question, text me. So if I don't know, you can't ask. Yeah. So there you go. No, I've got two more questions.
That's
right.
okay.
First one is, now you're friends with a few VCs. You hang out quite a bit with those kind of folks. What have they taught you?
Well, I think that, it's interesting. I mean, just to pick some simple things that you learn, and that some of it does go to failure. You know, you could have you could invest, and that risk is okay. So as an example of somebody, I'll just pick Moderna as an example. Let's say somebody invested $1 in, 100 companies and they all went bankrupt, but you invested $1 in the beginning when Moderna was just starting, you would have made a lot of money. And so that it's not, I mean, you want to make everything as successful as possible, but I'm sure Nubar Fayan, who started Flagship, they did very, very well. And I think that's one thing I'd learned. But I mean, there's a lot of other things. I mean, that, Terry Maguire, who's at Polaris, he's always had a number of good sayings. Like, I mean, one, they're not all unique to him, but he says, well, he views himself as a coach, and the people that start the company are players, and he wants to be a good coach. And then one thing he said that a lot of people, other people said too, but that, perfect is the enemy of good. Simple sayings, but if you think about those kinds of sayings, they make a lot of difference. Another one that he said, and I feel like when I look back at the companies I've been involved with, the most important thing has been, even though I'd like to think it was the science, and the science is important, has been the CEO. And Terry always says, well, the issue with the CEOs is the problem with the Bs. So I said, well, what does that mean? He said, well, Bob, he says, look, if somebody's an A person, that's great, you're all set. He said, if somebody's a C person, then you fire them. And he said, but a B person is somebody that's not an A person, and you keep hoping they'll get better, and they don't. and so I think that there's a lot that I've learned from different VCs.
I love that. I think that's great, the B person. Yeah. I always thought the B kid, you back the B kid because they try harder than the A kid, but you maybe look at it a different
it's hard
way.
Innate. A lot of these things are innate qualities,
Yeah.
It's hard to make somebody a genius if they're not, or work 100 hours a week.
That's true.
Yeah.
That's true. And I've got a story to tell you. So I was at the hairdressers last week. So I know it looks good, doesn't it? Yeah, I've had
I
a
can
cut.
see what's coming.
I know. I sat. How do you know? I was sitting on that chair deliberately because that's the best part of my hair. Anyway, she's a bit of a science nerd, and I was talking about you, and so I was Googling you while I was at the hairdresser, and she said, "Oh, this guy," and I'm like, "What do you mean, this guy?" And she said, "This guy is the reason why your hair's not frizzy, Michelle." And I went, "What are you laughing at, Tam?" And I said, "What do you mean?" And because I've got really curly hair, as you can tell, and I can tell you've got curly hair. Yeah. So she said, Living Proof, this hair product that you can get from Mecca, but I love it. And she said the reason, he's the inventor of Living Proof. He stopped hair going frizzy. It's true. I have Living Proof in my hair today. I'm living proof of the value that this man has created. But what a bonus to create a whole set of, hair products. I bet you weren't trying, or does your hair go really frizzy as well when it gets wet?
It does, but what happened? But maybe just to tell you the story, it's actually interesting. So one of the places, and I mentioned them a little bit before, that's given us a lot of funding for, medicine has been Polaris Ventures in Boston. And Amir Nishat, who was actually also one of my PhD students, came to see me, must have been around 2005. He said, "Bob, we've decided we want to start a hair company." And I said, "Really?" He said, "Well, can you help us?" So actually that was the first problem that they came up with. And we looked at it scientifically, and it may sound obvious, but at that time, pretty much every company that made, anti-frizz products used something that was like silicone, and it doesn't work well. And we figured out something, again, from a scientific basis that worked a lot better. and patented it, and that ended up, it worked really well. On the other hand, cosmetics is very different. So I remember we hired this woman who had a Harvard MBA as vice president of marketing, and she told me one day, she said, Bob, and it wasn't just, by the way, the anti-frizz. We came up with molecules that gave more body and all kinds.
I know,
of
right here.
Yeah. So you're yeah, obvious.
It's a foam.
Well, actually, just to make a sidestep before I tell you the rest. So what they did is the marketing people is really important. So they combined the anti-frizz thing with the body thing and put it in a shampoo, and they called it PhD. And that's perfect hair day. But I didn't think of that. But anyhow, just to tell you the rest of the story on the company. So we actually came up, there must be about 50 products, and and a number of my students work there. But so Grace Ray, she had the Harvard MBA, and they hired her as vice president of marketing, and she later became CEO. But she said, well, Bob, I've done this analysis. She said 95% of the people who use this reuse it, 95% like it, and less than 1% even know it exists. So they said, what we need to do is, get somebody that's more well known to the public than say you are, or something like that. So they ended up getting Jennifer Aniston involved in the company.
I know, I Googled that too. Yeah.
And she actually would come to my office and ask me questions. Questions and ask me questions on nanotechnology. But she was great.
You're such a name dropper. You did Bill Gates, and now you're doing Jennifer Aniston.
Well, it's the truth. But you obviously Googled it. But that actually also is important. So you had a combination of good science and good marketing. And
she's got the best hair.
Well, she told us that too. So
yeah. It's in her contract.
yeah. She said that, well, she's worth a lot of money and a lot of stock. But that's okay. I think she was worth it. So anyhow,
she was.
Yeah, she was worth it.
Yeah.
So anyhow, that ended up doing really well too.
There you go. So there's a little ad there for Living Proof. So
So they sell it in Australia.
They do. They sell it at Mecca. And I'm now an advisor to Mecca. I'm now an influencer. Did you see that? Take a photo. Thank you so much. I'm going to wrap it up there. You've had such an enormous day. It's such a privilege to meet you. And what a great story that you've told. And a story, I think, in which we can take, those beautiful little pearls from that story and retell them and retell them and retell them. So thank you very much.
Well, thank you. It's been a pleasure and an honor. Thank you.
I'm going to let you sit down.
Thanks so much. Thank you.